Welcome to the JCMS Web Basic Training Video Tutorial Program. In this video, I'll show you an easy-to-use visualization component which will provide you with a high-level dashboard-like view of your strain viability. Let's get started. Start by logging into JCMS Web using MTS Admin or your own credentials. Once you log in, you'll see the JCMS dashboard, and you'll notice two visualization components, strain viability and pedigree tree. This tutorial will focus only on the strain viability component. Click on strain viability. Once in strain viability, click the plus icon to expand the filter window. You can choose which information you'd like to see in the strain viability by using these filters. I will select all owners and all strains, and then click Submit to do a search on this criteria. You can now see there are several circles which represent different strains. The circle size is correlated directly with the number of live mice in the strain. The larger circle indicates a large number of mice, and the colors represent a number of factors from mouse sex to age to number of mice per strain, and I'll explain how to set the minimum and maximum for these factors and how they relate to the colors in a few minutes. If I hover over a circle, you'll see a gray box with some important information. The strain name, total mice, green status females, yellow status females, red status females, green status males, yellow status males, and red status males, the total matings, and the total number of cages. So what does that all mean? Having green status males or females means that the mice with this strain are still at a good age for breeding, or that there are enough of each sex. For example, if the mice are older, or the number of mice in this strain drops below a certain threshold, and this threshold can be set in the administration screen, then the color of the circle would turn yellow. And if the age of the mice is significantly old, or there are only a couple of mice left with this strain, then the circle would turn red. As you can see, these circles are yellow, and these are red, because the mice within these strains are either getting too old or the quantity is getting low. You'll also notice that when I hover over a circle, other smaller circles appear within the circle. Those smaller circles show the genotype of the mice with this particular strain. So if you hover over a genotype circle, you can see how many mice with this strain have this particular genotype. A gray circle means that some mice with this strain have not been genotyped, and again, you can see how many by hovering over the gray circle. This visual component is important because you can see which strains need attention and which strains are in danger of becoming extinct. Now I'll navigate to administration, which you can only access if you have administrative rights. If you click on mice in the left navigation, and then click on strain, you'll see a list of all the strains in your database. If you scroll over to the right, you'll see for each strain you can set a min number of males, min number of females, max age of males, max age of females for the yellow line viability, and the same for the red line viability. As you can see, I have already set the mins and maxes to what I want for each strain. So for a DBA2J, I set the minimum number of males that would produce a yellow circle in the strain viability would be 8 or lower. So if I have 8 males or less, the circle in the strain viability would be yellow. Now if the number of males went below 5, then the circle would go from yellow to red, meaning I have 5 or less number of males left with that strain. So anywhere from 1 to 5 would be a red circle, and then 6, 7, and 8 would be a yellow circle, showing that I have 6, 7, or 8 mice left, and then anything above 8, 9, 10, 11, and so on would show a green circle. Same goes for female mice. In this example, if I only have 15 female mice or less, I'll have a yellow circle. Or if the female mice count gets down to 8, then the circle will turn red on the strain viability. So you can set these defaults to anything that you want. And the same goes for age. I have 100 days for max age of males and for yellow viability, and 80 for female. And if you scroll down to see the max number of age for red, it's 80 for males and 100 for females. For example, once a female mouse in this strain hits 80 days old, the circle would turn yellow. Then if the age reached 100 days old, that circle would turn red. So as you can see, you can set all this criteria. And once you do that, you'll be able to track your strain viability using the strain viability visualization tool. That concludes our training for the strain viability visualization tool. For more information or to post questions, visit our website at colonymanagement.jax.org.